Neural networks have revolutionized the world of finance by enabling cutting-edge applications such as stock price prediction, risk analysis, and fraud detection. In this video, we'll delve into the world of convolutional neural networks, recurrent neural networks, graph neural networks, transformers, and long short-term memory networks, exploring how these advanced structures are transforming the financial industry. So let's get started with understanding what is a convolutional neural network. Basically, a convolutional neural network is a type of artificial neural network commonly used in image and signal processing, including financial data analysis. It is designed to recognize patterns in data, such as identifying features in financial charts or predicting stock prices. In simple terms, a convolutional neural network is like a machine that processes data by breaking it down into smaller parts called features. And these features are then analyzed to identify patterns and relationships that can help make predictions or identify important trends. For example, in the finance domain, a convolutional neural network can be trained to analyze charts of stock prices to predict future price movements. The input data would be the chart itself, and the convolutional neural network would learn to identify patterns such as rising or falling trends, support and resistance levels, and other important features that can help make prediction. So basically, this convolutional neural network would process the chart by breaking it down into smaller sections of filters. Each filter would focus on a specific feature, such as a sharp upward or downward movement in the price. The filters would then analyze the data to determine whether the feature is present or how strong the feature is. So once the convolutional neural network has analyzed the chart, it can output a prediction of the stock's future price movements. And this prediction could be used for trading decision, risk management, or other financial applications. So to summarize this, we can say convolutional neural network is a machine learning tool that processes financial data such as stock charts by identifying patterns and features. And this can help make predictions and identify important trends in financial data. Next comes recurrent neural network. Now this recurrent neural network is a type of artificial neural network that is designed to process sequential data such as time series data or natural language processing task. In finance, it is commonly used for tasks such as predicting stock prices, analyzing trading signals, and generating trading strategies. In simple terms, a recurrent neural network is a type of neural network that remembers and processes data from previous time steps. So it's like a machine that can remember the past to make better predictions about the future. For example, in the finance domain, a recurrent neural network could be trained to predict the future price of a stock based on the historical price movements. Here, the input data would be a sequence of past price movements, and the recurrent neural network would learn to identify patterns and relationship between the past and future price movements. The recurrent neural network would process the data by passing it through a series of neurons, which are likely tiny processors that analyze the data. And here each neuron would take the input data, pass it along to the next neuron along with the memory of the previous data that it processed. So as the recurrent neural network processes the data, it builds up a memory of the past price movements. And this memory is used to make predictions about the future price movements. For example, if the recurrent neural network sees a pattern of rising prices followed by a sharp drop, so it might predict that a similar pattern will occur again in the future. Another example of recurrent neural network in finance is in generating trading strategies. A recurrent neural network can be trained on historical data to identify patterns in market trends and then use this information to generate trading strategies that can take advantage of these trends. So to summarize this, we can say recurrent neural network is a type of neural network that processes sequential data and remember past data to make predictions about future data. It can be used in finance for tasks such as predicting stock prices, analyzing trading signals, and generating trading strategies. Next comes graph neural network. Now this graph neural network are a type of neural network that is designed to process data that is represented as a graph, such as social networks, recommendation systems, and financial networks. In the finance domain, graph neural networks are used for tasks such as network analysis, fraud detection, and portfolio optimization. In simple terms, graph neural networks are like neural networks that can analyze complex relations between the data points by representing the data as a graph. For example, in the finance domain, a graph neural network could be used to analyze a network of financial transactions to detect fraudulent activity. Here the input data would be a graph where each node represents a transaction and the edges represent the relations between the transactions. So the graph neural network could learn to identify patterns and relation between the transactions that are indicative of fraud. The graph neural network would process the data by passing it through a series of layers. Here each layer would analyze the data by looking at the relations between the nodes and edges. For example, a layer might analyze the frequency of transaction between certain nodes or the amount of money involved in the transaction. So as the graph neural network processes the data, it builds up a representation of graph, which captures the relationship and patterns between the nodes and edges. This representation can be used for various tasks such as detecting fraud, identifying key players in the network, or optimizing portfolios. Another example of graph neural network used in finance is in recommendation system. A graph neural network could be used to recommend financial products to customers based on their past transaction and relations with other customers. So to summarize this, we can say graph neural network is a type of neural network that processes data represented as a graph. It can be used in finance for tasks such as network analysis, fraud detection, and recommendation system. It analyzes the relationships and patterns between the data points in the graph to make predictions or insight generation. Next comes transformers. Now these transformers are a type of neural network architecture used primarily in the natural language processing. They were first introduced in the groundbreaking paper Attention is All You Need by Vashwani et al. In 2017. So in simple terms, transformers are neural networks that use a technique called attention to process sequential data such as text. Attention allows transformers to focus on specific parts of input data when making predictions, which can improve accuracy and efficiency. In the finance domain, transformers can be used for tasks such as natural language processing of financial news, sentiment analysis, and text classification. For example, a transformer could be used to analyze financial news articles and determine the sentiments, that is positive, negative, or neutral of the article. The input data would be the text of the article, and the transformer would learn to identify patterns and relations between the words and phrases that indicate sentiment. The transformer would process the data by breaking it down into smaller pieces called tokens. It would then pass these tokens through a series of layers that use the attention mechanism to analyze the relations between the tokens. For example, a layer might focus on a specific word in the article and analyze its relation with other words in the sentence. So this allows the transformers to understand the context of the word and make predictions based on the relations between the words and the phrases. Another example of transformers used in finance is in trading signal generation. Here the transformer could be trained on historical market data and news articles to identify patterns and relations between the market trend and news articles. So this information could then be used to generate trading signals that can take advantage of these patterns. So to summarize this, we can say transformers are a type of neural network architecture used for processing sequential data such as text. They use the attention mechanism to focus on specific parts of the input data while making predictions. In finance, transformers can be used for tasks such as sentiment analysis, text generation, and trading signal generation. And finally comes long short-term memory. Now this long short-term memory is a type of recurrent neural network that is designed to handle sequential data by learning long-term dependencies within the data. Long short-term memories are particularly useful for tasks that involve processing time series data such as natural language processing or financial time series data. So in simple terms, long short-term memories are neural networks that are able to remember information for extended periods, which allows them to process sequential data more effectively. In the finance domain, long short-term memories can be used for tasks such as time series forecasting, anomaly detection, and sentiment analysis. For example, a long short-term memory could be trained to predict stock price based on the historical data. Here, the input data would include features such as stock price, volume, and news articles. The long short-term memory would learn to identify patterns and relations between these features over time and use them to make prediction about future stock prices. Now, the long short-term memory process the data by reading each time step, that is the data points in the sequence, and update its internal memory based on the current input and the previous memory states. This allows it to remember information from earlier in the sequence and use it to make predictions about the current time step. For example, an LST might remember a significant event from the past, such as a major merger or acquisition, and use this information to inform its predictions of a stock's future price. So another example of a long short-term memory used in finance is in anomaly detection. A long short-term memory could be trained on normal market behavior and then used to detect unusual patterns or spikes in data that may indicate fraudulent activity. So to summarize this, we can say long short-term memory are a type of recurrent neural network that is designed to handle sequential data by learning long-term dependencies within the data. In finance, long short-term memory can be used for tasks such as time series forecasting, anomaly detection, and sentiment analysis. Thank you.